So you ask yourself, when will I ever need this? Well, let's take a look at a real-life example that you are going to encounter every single day. A firework is launched upward from a safe surface. The height of the firework in meters after t seconds is modeled by the equation h equals negative 4.9 t squared plus 49t plus 1.5. First of all, don't get overwhelmed by the decimals. This is just a regular quadratic equation in standard form. This is a real life scenario, and in real life, we don't always have perfect whole numbers. We have decimals, it happens, but it doesn't really change anything aside from the way that it looks. It might look a bit more intimidating. Also, here we are using h and t instead of y and x. T is still the independent variable, and h is dependent. The question asks us, at what height was the firework initially launched? So let's just take a look at what this looks like if I were to graph it into Desmos. You'll notice that it is a graph that is facing downwards. We can identify the intercepts and the vertex by looking at the graph. We won't be able to see them just by looking at the equation because it is in standard form. When I'm asking for the height that the firework is launched from, well, we launch our firework when time is 0. At t equals 0, that means that I'm starting to count. So I've launched my firework, I start the timer. So t equals 0 is when it is initially launched. So I'm trying to find out what is the height when time is 0. So what I'm going to do is I'm going to substitute t equals 0 into the equation. This is just all going to give me 0. This is all going to give me 0, and I'm left with 1.5. So that means that the height of the firework when it is launched is 1.5 meters, and you can even check that on the graph. You will notice that this 1.5 was actually the c value in my equation, and that's just always going to be the case. This value here is your y-intercept or your initial value. So I'm going to first wrap this up, and I'm going to say, therefore, the firework was launched and you could also make a note that in standard form, C is our y-intercept or our initial value. So you can add that to your notes. The second part of the question. Now, let's take a look at this second part. What is the maximum height of the firework above ground? So we are looking for that very tip of the parabola, and that would be the maximum value when the parabola is opening down. There's actually 3 different strategies to solving this question. So I'm going to show you 2 of the ways today, and the third way we're going to take a look at later. The first strategy is to just graph it. So if I look at the graph, I can see where the vertex is. and that will be my maximum value. So I can see by the graph that the max is 124 meters. The second strategy is algebraically to find the vertex. Okay, so in order to find the vertex, I need my x-intercept. Using my x-intercepts, I can find the axis of symmetry, and then using the axis of symmetry, I can find the y value of the vertex. So I'm going to start off with my x-intercepts. You will notice that this equation is not factorable, so I'm actually going to have to use the quadratic formula. And it's negative b plus or minus the square root of b squared minus 4ac over 2a. So I know that my a in this case is negative 4.9, my b is 49, and my c is 1.5. So those are the values that I'm going to substitute into the formula. Okay, and I'm going to simplify this. Okay, so this means that there are two options. All right. And be careful when you're putting this into your calculator. I ran into some issues with BEDMAS when I tried to do it all in one step, so make sure that, that you practice putting that into your calculator. So those are my x-intercepts. I still don't have the vertex. That's what I'm looking for, the vertex. So what I can do is I can use the x-intercepts to find the axis of symmetry, because I know that the vertex is going to lie, if it's going like this, and this is my axis of symmetry, my vertex is going to be on it. These are my x-intercepts. So I know that this is going to lie in the middle. So I'm going to find the axis of symmetry. Okay, and I'm going to find that by adding the x-intercepts and dividing by 2. And I get 5. I'm going to plug this value into the equation. So my x, or actually in this case it's not x, I'm using the variable t. So I'm going to substitute it into the equation. And I'm going to simplify. And I get 124, just as I did in the other one. So that means the maximum height of the firework is 124 meters.